Hey, good morning and welcome back. We're back here live with you looking at the line of best fit, Chapter 4, Lesson 8. And you can see from the screen our objectives are to determine a line of best fit. We've done that for several years now. We're going to be using the graphing calculator to make it a little more technical for linear data. And we're going to determine and interpret the correlation coefficient. Those are big words. Vocabulary for this lesson include the residual, least squares line, the line of best fit, linear regression, and the correlation coefficient. A residual, now just off the top of our heads right now, of course this doesn't make sense until we get into the math of it, but I just want you to know that these are here, defined for you if you want to put those in your notes. The residual is the signed vertical distance between a data point and the line of fit. The least squares line for data set is the line of fit for which the sum of the squares of the residuals is as small as possible. The line of best fit is the line that comes closest to all the points in the data set using a given process, which we are about to learn. And our linear regression, which is a computation that we're going to be doing on our calculators, the process of finding the least squares line. The correlation coefficient is R. We're going to be finding that with our calculator. R needs to be between -1 and 1, and it's describing how closely the points in a scatter plot cluster around our line of best fit. So here we go. Let's get right into this. It says 2 lines of fit for this data. We see our data down at the bottom, 1, 7, 2, 5, 3, 6, and 4, 9. And they've given us 2 different lines, which could be the line of best fit, both moving through the data fairly equally. Well, our job is to determine which one of those lines is the closest. We're first going to look at this line, y equals x plus 4. And everybody, with the knowledge that we've gotten from Chapter 4, we can see that our y-intercept right here, y-intercept positive 4, and we can see that our slope is 1. So we're going to look at our line. Yes, positive 4, we went up 1 over 1. This is absolutely our line. What we're going to do is compare the sum of squared residuals. Now these residuals are the distance from the point to the line of best fit. So this would be a value of 2. We're going to square that. Down here you can see we've squared 2 and gotten the product 4. We're going to take the residual -1. This point lies 1 unit away from the line. Here another -1. We've taken both of those and squared them, of course, and got a positive distance of 1. And the point 49 from the line lies 1 unit as well. And we can see we've taken the sum of all of those residuals, the sum of the squares, and added those up. So for the first line, we have an R value of 7. Let's look at our second line. We have the line y equals 2x plus 2. Let's check and make sure. This is our blue line. We have a y-intercept of 2. We have a slope of 2. Let's check that out. Y-intercept 2. Then we went up 2 over 1. We're checking with the same data values, 1, 7. We can see that lies 3 units from this line. We've taken 3, squared it. Likewise with the -1 and the -2 value, those points lying 1 and 2 and 1 units from the line. So we're going to take those and square them and add them up. And we can see and compare, if we go back here, the first line had an R value of 7. The second line, an R value of 15. And so it is the content of the lesson, the line y equals x plus 4 is our better fit. There's 2x plus 2. Here we have x plus 4. And we can see this line fits far more closely to those correlation values. So right here we see the problem. Check it out, number 1. And it says the 2 lines of fit for this data are given. Y equals -1/2 x plus 6 and y equals -x plus 8. And you guys, with your vast amount of knowledge on linear functions, you can look at those and see we have a y-intercept of 8 in the red line, and we have a y-intercept of 6 in the blue line. Both are negative slopes, so those check out. The red line, -1, much steeper than the blue line, which is -1/2. So what we're going to do here, and check it out, problem number 1, for each line, find the sum of the squares of the residuals and figure out which line is a better fit based on example 1 that we just went through. Please do that and come right back here for the solution. So you can see here on the screen the blue line in blue. We've counted our residuals, the points 2, 3, 4, 6, 6, 1, and 8, 4. The blue line from the first point 2, from the second point 2, third point 2, fourth point 2. All of those written out in purple. So we can see the value of 2 squared times 4. 4 times 4 is 16. And our red line, I've placed those values in. We can see right here with the very last calculation that we made, we have 4 squared. We have 16 already. So we can see that the line y equals -1/2 x plus 6 is our better fit. As you can see in example 2, we're talking about cities, latitudes, and average temperatures. What we're going to want to do with this type of intense data is use our calculators to do all the work for us. So I want you to grab your calculator and make sure that you refamiliarize yourself with the function editor right here, the y equals button, and we're going to be inputting this data into our table. So for that, I just want to start out by saying we're going to be going to our stat button, and we're going to edit. Let's get this up here so we can see it. We're going to edit lists. We've gone over this before. I want to make sure that you understand when I go up to list 2 and I want to clear the data, I want to clear it and then hit enter. I don't want to delete it. That will delete L1 or L2 altogether. So to the L1 button, and then we're going to hit clear, not delete, and then back to enter. And what I'd like you to do right now is take the information found in the check it out problem number 2 and put that in your list 1 length, your list 2 for price, and come right back here and we'll talk about how to deal with that data in the calculator. So after we get the data from check it out problem number 2 into the calculator, it says find an equation for a line of best fit. What this calculator is actually doing for you is that which you did in example 1, finding those correlation factors, squaring them, and finding that R value, the regression factor. So we're going to do this with the calculator now. You can see I've got list 1 and list 2 in here, and the directions from example 2 clearly state how we want to go ahead and do that. After we've pressed the stat button to get our list up, we're going to press stat again, and we're going to this time calculate. We know that our data is linear, so we're going to go down and choose linear regression, ax plus b, and from here we just press enter. We're telling the calculator to take the data from list 1 and list 2. This is just a double check right here. Make sure that you put them in those lists, and we're going to go down. Before we stored the regression equation, now we're just going to calculate. We're going to calculate the values a and b. Now if you look at what a and b represent in our linear function, ax plus b, b still looks like our y-intercept, and a is simply taking the place of m, our slope. So our slope for this one, you should have, if we rounded this, we would have y equals approximately 0.04x plus 6.38 or 39. Now it says interpret the meaning of the slope and the y-intercept. Well, if you look, the slope or the change in y is simply the change in the cost per the length of the yard. So this is the equation that we came up with using our calculator, which seemed to be probably just as long as doing it from a graph, but it said Knitmart also sells yarn in 1,000-yard balls. Use your equation to predict the cost of this yarn. So the length, we don't see 1,000 in our table up here in the length, but we know that our function is y is equal to the cost per yard. So we're going to stick in that independent value, 1 yard. So we have 0.04 times 1,000 yards plus 6.38, giving us the cost, approximate cost of 1,000 yards of yarn, and you should get for that roughly $46.38.